Hello everyone. Today let's solve the problem number 622, design circular queue. Right. So what the question states here, we have to design a circular queue using the linked list. We have to design the circular queue using the linked list. Let's come to the example part here. You'll understand this one better. We have to create we have to design the circular queue. This is based, this is design based problem, right? So we have to design the circular queue. So I'll just write CQ here, nothing but we have to this one design the circular queue using the linked list. So we shouldn't be making use of built-in queues. We shouldn't make use of the built-in queues. Again, I'm telling we shouldn't make use of built-in queues, right? So just give me a second here. Built-in queues. Again, I'm telling this part is very important, man. So we shouldn't be making use of the built-in queues here. So we should be, we have to design the circular queue using the linked list. So again, I'm telling we shouldn't be making use of the built-in queue. Basically, it has to support the circular queue that we design. It has to support four operations, right? One is enqueue, one this one, sorry, six operations, not the four operations here. Enqueue, you can clearly see here. This one, dq, where is dq? This one, dq. Rare, rare is fine. Is full, rare, front they have not mentioned here, but also front here. Just add this one as well. Front, this one is empty and is full. Is full we have, again is empty we don't have, and also add is empty. These six operations we have to, it has to support whatever the circular queue we designed, right? It has to support these six operations basically. This one, enqueue, dq, is full, is empty, and rare and front, these six operations, right? So it should be a fixed size queue with a circular behavior. It should be a fixed size queue with a circular behavior. We cannot add more elements when full. We must be making use of the, or we should be reusing the space, in simple terms, right? We cannot add more elements when the queue is full basically. We should be making use of the, or we should reuse the space. We have to track front and rear using the linked list logic. And again, this part is very important, man. So basically they have asked us to track the front and rear. They have asked us to track the front and rear. So keep this in mind as well. This part is very important as well. Just keep this in mind, right? So I hope the question part is completely clear. I hope the question part is completely clear. Let's come to the approach part here. Let's consider the example, this example one itself for the this one approach. So basically what we'll be doing in the question itself, they have asked that we have to go with the linked list. We shouldn't be making use of the built-in queue operations. Instead, we have to make use of the linked list. We have to make use of the linked list. So we will be going with the linked list approach, means the operations that the linked list provides. So we'll be making use of the operations that the linked list provides basically, right? So I hope this part is clear. So here first what we will do, we have my circular queue of 3, my circular queue of 3. Just keep this in mind. In the input they have strictly mentioned we'll be going with the enqueue, dq, is this one is full, as well as the rare, these four things, right? So here in this case, this one my circular queue, this is nothing but the, what do you call, initialization part, and the return value will always be null, and the return value will always be null here. Just keep this in mind. Enqueue, for the enqueue and dq, the return value would be this one boolean value, either true or false, either true or false, right? So for the enqueue and dq, the return value is either true or false, right? For the rare, for the rare, the return value is number, the return value is number, right? So integer basically, not the number, integer. You can, I'll just call this one number. The return value is integer. The return value is integer in JavaScript. Basically, I'm from the mainly from the JavaScript background, right? So I have done enough JavaScript problems. Means I have solved n number of JavaScript problems whenever I do it in Java or any other language. So basically, I'm good with JavaScript and Java both. But whenever I have spent enough time on the JavaScript, means whatever you do, it makes me remember of the JavaScript. It makes me remember JavaScript. So here in this case, it would be the return value would be integer, right? So this is fine. Let's come to the front part here. This one, let's come to the front part here. Front also integer itself, right? Front also, this one also, this one we have to consider integer. Basically we don't have the return value here, we will not be considering front at all. So there they have not given it all, right? Front also integer itself, man. Front also integer. For the this one, what we need to return, where is it? We have NQ and DQ, this is fine. Yeah, my circular queue, this is null. For the NQ and DQ, we have this one, what do we call? What do we call? For the NQ, DQ, and is full. For the NQ, DQ is full and is empty. So it has the return value has to be either true or false. I mean Boolean value we need to return, right? So for the this one rear and front, we need to return integer. For the rear and front, we need to return integer. Just keep this in mind, right? So let's go step by step. Now let me delete this one. Just give me a second here. So yeah, just give me a second. 1 second. 1 second. So here this is fine. Let's consider my circular queue of 3. My circular queue of first one 3. What we'll do, we will create a queue of size 3 initially, which is empty. We will create a queue of size 3 initially empty. So here in this case, we have my circular queue of this one 3 initialization part. We have to create the queue of size 3 initially empty, right? So this will be what do we call nq of 1, nq of 2, nq of 3. So here next part we have to go with nq of 1, 2, 3. Initially we have created this one. We have created q, this one. Let's consider this one here, space 3, right? So this 1 2 3. So now we are making use of the nq. Now we are making use of the nq. So nq of 1, nothing but we are adding 1. Nq is nothing but pushing, right? So we are adding 1 to the queue, and next here we have the operation to nq of 2, we are adding the number 2, and nq of 3, we are adding the number 3 to the queue. This is fine. I hope this part is clear, right? So next we have nq of 4. NQ of 4, this one miserably fails here. This one miserably fails here for the NQ of 4, because see here, we went with the initialization part here. My circular queue of 3 means we are creating the queue of size 3. So this is so we don't have the slot for 4. We don't have the fourth slot at all here, right? So here we cannot add the NQ of 4. We cannot add the NQ of 4 here, right? So here in this case we will return the boolean value false. As there is no slot or memory, what we will do, we will return the boolean value false instead of true. So for this one we can add, so we will go with true. For 2 also we can add, 3 also we can add, we will go with true. So and also the return value of the initialization part, nothing but the my circular 3 of this one 3, this is null basically. I hope till here everything is fine, right? So next step what we will do, we will go with the nq of the empty array. We are going with the nq of the empty. So this one, what do we call, so here we are done with NQ. Oh, sorry, this one, not the NQ basically. So NQ, these three we have already used, and this fourth one miserably fails here for this one, NQ of 4. So now we have rare. Now we have rare. Rare means what we need to get here. Rare means what we need to get here. We are making use of the queue here. Means queue follows first in, first out. Queue follows first in, first out. Rare means in this sense, we have to return this one, rare, this one, right? So here 3, we have to get the value 3 while we perform the rare operation, right? Next what we will do, we will be going with the is full. We will be going with the is full of true, is full of this one basically, right here. This one is full operation we are performing. We are left with, so sorry, just give me a second here. Until here I hope everything is clear. Let's consider is full here. Is full, this one is full of this one we are considering, right? So this is fine. Is full, yes, it is full, right? So we had only this one, 3 slots in the queue, that is full by 1 2 3. So while performing the rare operation we got 3 here, first in first out queue. So next is full, yes, it is full. So we will return the boolean value true here. In this case we will return the boolean value true here. In this case we are left with dq. So we have to remove the element, right? So we have to go with dq operation, right? Next here, yeah, we have here in this case we are going with a c here. We are going with a my circular q dot dq. So we have to return true. we can, right? So we can perform the operation. This is true, right? So next what we will do, we will go with NQ of 4. NQ of 4, we have one more slot now. We have one more slot now. So what we will do, we will push 4 here. So after dequeuing this one, we will push 4 here. We will push 4 here, right? So after pushing 4 here, so we have to return the boolean value true here. We can, right? We have the slot. So in the place of 3, we will be going with 4. We'll be pushing 4. So the final one here is rare. Final one is rare. Rare of this one. When we perform the rare, we have 4 here now. Instead of 3, we have 4 here. When we are getting by making use of the rare, so this will be, we have to return the value. It is of the type int, right? So the return value is integer, right? So here we'll be returning 4. So this is how we got 4 here. So this is how we got the output: null, true, 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 false, 3, true, this one. So this itself we have to articulate in the form of code. Now whatever we discussed in the approach, this itself we have to articulate in the form of code, right? So again, we will, as I have said, we made use of the this one, what do we call, linked list for this one instead of the direct queue operations, right? So now what will be the time complexity and the space complexity before writing the code? What will be the time complexity and the space complexity for the code that we'll be writing? So basically the time complexity would be big of 1. So the time complexity would be big of 1 for all the operations. For all the operations, the time complexity would be big of 1 for all the operations. Means insert or remove from head and tail will take constant time, right? Will take constant time. So overall time complexity would be big of 1. I mean for every operations, right? For all the operations or for each operation. So overall time complexity would be big of 1 here. So what would be the space complexity here? Space complexity would be big of k. The space complexity would be big of k here in this case, right? The space complexity would be big of k. Where what is k here? K is nothing but the capacity. K is the capacity, right? K is nothing but capacity. Capacity of what? We are creating up to k nodes max, right? Nodes, capacity of the node. So here we are creating up to k nodes max, right? So overall space complexity would be quite obviously big of k. The time complexity and the space complexity for the code that we'll be writing in the future would be big of 1 and big of k, right? Respectively. So this is it for the what do you call, complexities part. Now as we are completely familiar with the approach and the complexities part, let's start writing the code, right? We are good to write the code. Let's start writing the code. First part, what shall we do? Let's define the node class. So here, before coming into here, let's do one thing. Let's divide this one, define the node class. So I'll just go with class node. This is fine. So within this one, let me go with int val node. Next, this is fine. Node of, so this will be int value. So this is fine. Within this, let's go with the initialization. Nothing but we are initializing this dot val to value. So this is fine. Let me come out of this one entirely. Now let's go with the, we need front pointer, rear pointer, current size, as well as the max allowed size. Accordingly with the approach, whatever we discussed, we need front pointer, rear pointer for sure, and also the current size. Current size means we have to go with the particular size they have given here, initialization part here, this one, my circular queue of 3, right? So we need the current size as well, and also the max allowed size. We have to go with the max allowed size, nothing but the capacity, right? These 4 things we need to go with. Basically, let me come here and write here private node. So this one, first let me consider head, nothing but the this one, front pointer. For the rear pointer, I'll just go with the private node tail. And for the this one, what do we call, for the size, let's go with size itself. So this will be private, so instead of the node, this will be integer. For the rear and front, we have to go with, I mean this is size, right? Sorry, this has to be integer. So here, this one, speaking of, this is fine. So the next thing is capacity, maximum allowed size, right? So here I have to go with private int capacity. So this is fine. So let's come to the initialization part, nothing but the line number 16 here. Let's come to the main initialization part. Here we have to set the fixed capacity, nothing but here this dot capacity. So I should have copy pasted, man. So this is fine. So the next part is let's initialize the size to 0. So let's go with this dot size equals 0. The third this one is we have to go with the front and rear of the queue, nothing but here in this case this dot head, let's initialize this one to the null, and also the last line here, this dot tail equals null, this dot tail equals null. So this is fine. So let me come out of this one entirely. So let's move on with the enqueue operation. Let's move on with the enqueue operation or the enqueue method here, right? So within the enqueue, first the return value of the enqueue and dequeue is boolean value, right? So first, if you remember, if we cannot add the value to the queue, means by making use of the enqueue, if we cannot add the value, then we have to return boolean value false. So that itself is the base case, man. So we can write in this like in this way. So is full if is full this one, then what we need to do, we have to return false, we have to return false. This is fine. So the next part is we have to create the new node, we have to create the new node. This would be node new node new node. So this one we go with no new node equals new node new node of let's pass the value here, let's pass the value here. This is fine. Let me come out of this one entirely. So here now if it is empty, then we have to move the first node and we have to provide the circular link. So accordingly with the approach, if it is empty, then we have to go with the first node and we have to provide the circular link. So let's articulate the same thing in the form of code, whatever we discussed in the approach. So here if is empty, then we'll be making use of the operation is empty, right? So here that the this one linked list provides it, right? So here let me assign head to tail equals new node. This is fine, new node. So the next part here would be tail dot next. Let's assign this one to, this would be tail dot next. Let's assign this one to head, let's assign this one to head itself. So else if it is not empty, if it is not empty, then we have to attach the new node to the end, move tail to the new node and maintain the circular link. Again at the end we have to maintain the circular link itself. This remains same. Let me copy paste the same thing here. So here, yeah, let me paste the same thing here. Before this, so we have to attach the new node to the end, we have to attach the new node to the end, means you would have already guessed this one. So this would be tail dot next equals new node, tail dot next equals new node. Then after attaching the new node to the end, we have to move tail to the new node, means here let me assign tail to new node, let me assign tail to new node. This is fine, this is fine, right? So here we are done with this part. The next part would be we have to increase the size, we have to increase the size, then and we have to return true, means I'll just go with here, let's increment the size. We have considered size itself, right? Yeah, this is fine. We have to increase the size. This is fine, and finally we have to return the boolean value true, we have to return the boolean value true. So this is fine, we are done with this part. Let's move on with the dequeue part. Let's move on with the dequeue part or the removal part, right? So again, if it is empty, if the memory is it doesn't contain any value, then we have to return false, because we do not have anything to remove if the memory is empty, if the queue is empty basically, right? So here let's write the base case here. This is nothing but here if is empty, then we have to return false, we have to return false. This is fine. So the next step here would be if head equals tail, if head equals tail, then what we'll do, so within the if condition there is only one element, so we will assign head and tail to null. So we can just directly write, instead of head to null and tail to null, I'll just give here head equals tail equals null. So this is fine. So this is it. Next, else, so else if head is not equal to tail, then what we need to do, we have to move head, we have to move the head forward, and again we have to maintain the circular link. So this remains same, maintain the circular link. Let me copy paste the same thing over here. Before this one, before maintaining the circular link, so we have to move the head forward, means head equals head dot next, we have to move it forward, right? So this is nothing but head equals head dot next. So let me format the document once so that this looks good, man. So let me, yeah, this is fine. So again, now this time we have to remove this one from the queue. So this would be, instead of incrementing the size, we will be decrementing the size over here. And finally, we will return true. Exact same thing, but certain things are different. Here we are going with adding and making sure that if we can add the particular value, then we have to return the boolean value true. Here we are removing as we are performing the dequeue. So here what we'll do, whether we will check whether the element can be removed or not. If it can be removed, then we will return the boolean value true. If we cannot remove, here we have already written the base case. If it is empty, or if we cannot remove, then we have to return false in that case, right? So here this is fine, we are done with the dequeue part, right? So next we are left with front rear is empty and is full. For the front, what we will do, if it is empty, if the queue is empty, then we have to return -1, else we have to return the value of the head for the front. Easy. So I have showed this one, queue follows the order FIFO, right? We are making use of the operations of the linked list here. So we have to return the value of the head if element exists in the queue, basically, right? So here we can write in this case, if it is empty, we can just make use of the is empty operation. If it is empty, then we have to return -1. Return -1. If it is not empty, then we have to return value of the head. Value of the head, this would be head dot val. So this is fine. So let me do one thing. Let's go with the next step here. Rear. Front is completed. Now let's go with rear. Rear, what we will do here again, if is empty, then again we will return -1, right? So for the rear as well, for the rear as well, so same thing, but instead of the value of the head, we will return the tail value. We will return the tail value as we are performing this one, rear operation, right? So here we will go with tail dot value. Same thing, right? So I hope this part is clear. This is fine, man. This is easy actually. Front, rear, is empty, is full. So is empty, for the is empty, we have to check whether the size is 0, and for the is full, we have to check, we have to compare whether the size is equal to capacity, right? So that's it we have to do. For the is empty, so I can just return in this way, if whether size is equal to 0, we have to compare whether the size is equal to 0 or not. For the is empty, we are done with the is empty. For is full, what we have to do, we have to check whether size is equal to the maximum capacity, right? So here for the maximum capacity, we have considered the variable name capacity. Let me give capacity here. So we are done with the all the methods. I think we are done with the code. So let me clean this one. We have already discussed this one, so the code looks good, right? So let me format the code once. Yeah, now code looks good. Code looks good, right? So what shall we do now? Let me hit the run button. I hope this works for the sample test cases. Let's see. We have the compiler here. Node of int value. What is wrong here? The line number 7. So where I have given node of int value? Private. So this is fine. Private class. So yeah, here I have given this one, right? Small n I have given here. So there I have mentioned capital N. So this has to be capital N. Oh yeah, this is fine. Now still tail I have misspelled here in the line number 30. So just give me a second. So let me make this TIL. So this is fine. So here you can clearly see the sample test cases are getting passed. The sample test cases are getting passed, means the code works absolutely correct in this case. The code works absolutely absolutely correct in this case. Let's see whether this works for all the test cases or not. Let me hit the submit button. So here you can clearly see, man, all the test cases are getting passed, right? So the code works absolutely correct in this case. I hope the solution part is completely clear along with the this one, what do we call, approach and complexities. For now, this is it. Thanks for watching, guys.